I think we can start. So I'm going to start with a quick question. How many people here have kind of like installed a package for tutorial or something without actually inspecting what you are installing? Like pip install something, npm install something, right? So yeah, that's the attack surface that we are going to discuss today in this talk. And it is becoming, as we will see, pretty impactful attack surface. Quick intro about me. My name is Diptendu, currently work as a security researcher at SEMGRAD. So the agenda for today is we are going to go briefly over the history of NPM malwares, why specifically NPM, the attack vectors, how usually the attackers get in, the payload tricks, how they are delivered, the malwares are delivered, can AI help in malware detection, and the possible solutions. I'm going to read out some stats. In 2023, we saw about 5,000 malicious packages taken down by NPM. NPM is the package manager for the JavaScript ecosystem. And in 2024, that number climbed 10 times. So from 5,000 to 512,000 almost. Right? And the notable attacks were like the Luma malware, the executils, backdoor. Fast forward 2025, these were some of the most impactful supply chain incidents in order. The NX attack, the Chalk attack, Shai Hulud worm, somebody heard of it, and then we had Shai Hulud 2 as well. So these were the most impactful attacks of 2025. Why NPM, right? So why attackers choose this particular ecosystem? So first of all, NPM is everywhere, right? It's in your front end, it's in your back end, it's in your CI/CD. The entire of Web3 crypto is NPM, right? It is very easy to publish to NPM. Well, it was. It does not ask you for review. There is no sandbox. There is no question. You just you can upload anything you want. There is also something we call single function libraries. That is a part of the NPM ecosystem. So a library that has one specific job to do, right? So we'll see soon. And consequently, NPM has a large dependency graph. There is a study on GitHub which says an average NPM project has 10 direct dependencies and has 600 transitive, which is like the dependency of your dependency. Here is an example of a single function library. It's called isWindows. The purpose of the library is to tell you if you are on Windows or not. So many other libraries are built on top of it because maybe you want to do something on Windows, then if it's not, you want to do something else. Right? You can see the weekly downloads is about like 24 million. And this 20 lines is the entirety of the library. It's just doing one thing, is are you on Windows? That's it. So how do attackers get in? Usually there are 4 things that we have seen. Something is like randomly named malicious packages. Then we have typosquatting. Then we have something like dependency confusion. And finally, we have maintainer takeover. Randomly named packages. As we saw that we can upload anything to NPM. So I can create a package by my name and put something in it. Good or bad does not matter. I can upload it. But who is going to use a package with my name, right? So what's the purpose of random packages? Well, what we have seen is these are the test beds for actual attacks. So the attackers actually kind of refine their attack. They name random packages. They try and install and see is the attack going as planned. And once they have the actual thing, they will actually target the actual package that they are targeting. Typosquatting. Typosquatting is you make a spelling mistake and then you wanted to install something A and you install B. So for example, the most popular package on NPM is load ash, and these are all of the variations and all of them are malware. So this is an example called load ah, which is you're missing the S. This is a malware. But if you see on the right hand side, there are still 152 weekly downloads. So people are making typos still, right? So there is one good thing about it is NPM usually takes down these, and if you see the version, it says 001 security. So it replaces it and puts a message which says, hey, this is bad. Even if you install it, nothing will happen. Yeah, just highlighting the downloads. Yeah, so even if I want to install, like I tried deliberately to install Loda, it said, nah, this is a critical severity, don't use it. But the malware is already out, so no issues. Right, so dependency confusion is a very targeted attack. This was disclosed by a researcher called Alex Birsan. What it does is, in organizations, they have like their own internal packages, and they also have like public packages that they work with. What the attacker needs to know is some information about your internal package, like the name, basically. Kind of you can guesstimate it. And what they do is they, in the public repository, they would publish a version with a very high number, like 100.2. When you try to install the package, it goes and checks, is the public version higher? Yes, so it downloads the public version. But this is a very targeted attack. Some of examples were, like there was an internal library called auth PayPal from PayPal, and the attacker like created an auth PayPal library with version like 1000. Right. This is the most impactful pathway. Assume that I am the developer of TensorFlow or a popular package TensorFlow, right? So if any attacker compromises me, they have my tokens for maintaining TensorFlow. They can now release a new version of TensorFlow with the malware. What this does is, if you can compromise a maintainer using social engineering mainly, you can inherit all of the things. You can inherit my trust, you can inherit my users, downloads, everything. This has the highest impact. And all of the attacks we have seen leverage this pathway, compromising the maintainer, and then releasing the malware. This was the phishing email that was sent to the maintainer of Chalk debug package. They clicked on this, leaked their npm tokens, and the next version was a malware. Yeah, so here is just an example. NX 21.4.0 was good, 21.5.0 was bad. Compromise your token, release 21.5.0 with a malware. Now, how does the malware actually gets delivered? In every npm package, there is a file called package.json. It is usually the metadata of the package, which says who is the author, what is the first file to be run, what is the GitHub repo, and there are also tags called scripts. It was and it is for testing purposes. So, and it has pre-install and post-install hooks, which is like before install run these tests, after install run these tests. But you can do pretty much anything with that. So attackers usually leverage that post-install and pre-install hook. They can call node something, where something is the malware, which is pre-packaged, or we have also seen like curl external URL / pipe it into bash. Pretty much you can do anything. The types of payloads. One is like going from no defense evasion to highest defense evasion. No defense evasion is like readable code. So you can see, if you go through the code, you'll kind of like understand, yeah, this is doing bad. But then it comes minified, which is like shortened code. Then you have obfuscated code, which is meant to throw you off from your analysis. And then you have binary. So you package a binary and you execute the binary. Is the image clear? So this is from the NX supply chain attack. This is the package.json file. If you see, the post install says run node telemetry.js. This is the content of telemetry.js. And if you read through it, you can clearly see, okay, I'm going to create a GitHub repo. I'm going to look for name it singularity, and I'm going to like npm who am I and publish all this. So this is actually, you can read through it and find out this is not a good behavior. The TLDR for this is it collects your info, publishes to GitHub. The fun thing was inside this telemetry.js, there were some instructions that the malware actually looks for Gemini, Claude in your workspace. If it is, it then instructs it to do something bad, like look into the files, extract all the files, give me all the secrets, and then publish it to GitHub. Next, we come to an example of minified code. This was the Shai Hulud worm. If you look at the package.json, it is calling node bundle.js, and bundle.js is the malware. And so if you just like read it, it's very hard to read. It's not in normal format, but there are like beautifiers which can like make it somewhat readable. So like it is much more difficult than the readable code. That's the idea. What this does is it leverages a legitimate secret scanner called Trufflehog, scans for your secrets, finds your secrets, publishes to GitHub. It also has a worm feature. The worm feature is once you install it, it is going to look at, do you have access to other packages? Are you the maintainer of any more packages? If so, I'm going to use those tokens and create more malwares. That's how it keeps propagating. That's the worm feature. Obfuscated code. This was from the chalk debug attack. If you see the package.json, there is no pre-install, post-install. What this one specifically does is it has the obfuscation embedded in the index.js file itself. So when you install the package, you're not affected. If you import the package in your code, let's say import chalk, index.js will run, malware will run. So it is not, there is no pre-install or post-install hooks. This is how it looks like. This requires reverse engineering. This is obfuscated code. It is meant to throw you off. But thankfully, like there are researchers who have like reverse engineered it, and it is a cryptocurrency stealer. What it does, it has built-in attacker addresses, and if I am going to send a transaction to someone, it injects inside it and changes the target to the attacker's address. So you are sending the money to the attacker basically. The good thing was only $50 worth of crypto was stolen, so not a lot more damage. Shai Hulud 2, this is also obfuscated code, but this works a bit differently. So if you see the package.json, it says pre-install node setup1.js, and in setup1.js it says, hey, execute one environment.js. So it's like trying to go around it, and this is the one environment.js, and you can like kind of guess this is also obfuscated. It is the same info stealer, only it is leverages pre-install, that was leveraging post-install. This is a refined version of Shai Hulud 1, right? Shai Hulud 1 was minified. This is heavily obfuscated. What else it does is Shai Hulud 1 scans 20 of your repositories, like do you have access to 20 other repositories? This one scans up to 100. Do you have access to 100? And the bad thing is, after scanning for secrets, if it cannot authenticate with GitHub or NPM, it will wipe your drive. That's what it does. It created like at the time of discovery, there were like about 26,000 repositories out in GitHub. Like these people were affected, and it exported 3 files: cloud.json, content.json, environment.json. They were like triple base 64 encoded, but it's very easy to decode, like using CyberChef or something, and you can see the secrets. Right. Here is what we have, something called what is the window of opportunity for an attacker and what is the window of exposure for a defender. Right. So assume today after the end of the conference at 4 o'clock, I release a malware. Right. From that point onwards, there are many security vendors, individual researchers who are constantly checking and probing if the new version is a bad version or a good version. Right. From that point onwards, they start analyzing the library or the file or the version, package version. At some point of time, they will reach a conclusion, which is like, yeah, this is good or this is bad. If it is bad, they report to npm itself, and npm takes it down. So the package is no longer available. The version is no longer available. So my window of exposure is only that part from release to npm taking it down. We ideally want that window to be as low as possible, and with the with new tools, it is coming like down by a considerable margin. For the NX attack, this window was 4 hours. For Shai-Hulud 2, this window was 4 days. Because it's a worm, it constantly keeps propagating. So you need to constantly keep up with what is infecting next, what is infecting next. All of this has to be taken down. Ideally, we want this window to be as small as possible. Now, can we use AI to detect malwares? So this is a pure AI solution. Like I pull a package, run it through Claude or an AI like any other LLM. Is it good? Is it bad? Right? Let's look at the experiments. Readable malicious code for the NX library. Yes, it can. It can quickly tell you, yes, what I asked is like, can you read this code and tell me what it's doing? What is the intent of the code? And he said, short version malware. Quickly identify, right? Do we need to use deny by default? Not in this case, because we already know what it does. For Shai-Hulud, yes, it can. A bit more difficult than like readable code. For this one, Shai-Hulud worm, I used Claude. I think it was 4.5, and Claude said, no, this is good. There is nothing wrong with it. We'll come to like why this might be. Can we use deny by default? No, because there are legitimate packages which use minified code, right? So just the presence of minified code does not imply this is a malware. So we need to actually do the analysis and find out what it's doing. Next, obfuscated code. In this case, for the chalk debug attack, Claude actually identified it from the search patterns as, yes, this is bad, this is malware, don't use it. So for readable code, it did. Minified code, it did not. For obfuscated code, it did correctly find it. Shai-Hulud 2, 4.6. Like this is one of the recent attacks. So we had 4.6 by then. Was it able to detect? Yes, but not with the prompt, what is this piece of code doing? Because the malwares are like 10 MB, 12 MB. It is more than the context window. If I look at the tokens, it was like 2.6 million tokens. So what Claude did was to take the first 2,000 characters, last 2,000 characters, and that part was good. So it says, yeah, it is good. If you tune the prompt that they are looking to part by part, then it can find it, yes. So can we use deny by default? Generally, yes, because no legitimate packages has obfuscated code. They have minified code, but like obfuscation usually signifies something bad intent. Yeah, so what are the potential issues with full AI analysis is size of the file greater than the context window. You can't like, it's up to the model how it decides on that particular instance. False positives and negatives, sometimes it will say yes. If you run 100 times, 50 times it might say good, 50 times it might say bad. And there are adversarial code specifically to avoid static analysis, and attackers are also using prompt injection techniques. So there is an article by Checkmarks where the attacker commented on top of a function which was opening a netcat connection is, this is unimplemented, it is supposed to do this and this, and it ran through Claude security. Claude security said, yeah, everything is good. So what are the possible solutions? We can use specific tools like Socket Aikido. These are like paid tools whose purpose is to detect malware. So these are like vendor specific tools, but like what can we do for free? So one thing we need to avoid is the FOMO of the latest and greatest version, like usually pin packages to the version, but it has its downsides. The downside is like for a legitimate CVE like let's say React to Shell, where you need to update, you have to update. So it has everything has its pros and cons. We can use the ignore script so that the scripts does not get executed. The library will install, the scripts will not get executed. We can delay automatic dependencies, like even the paid tools also have it, like if a package is released in the last 24 hours, I'm not going to update it, because they are leveraging the window, because they know that if it is a malware, after 24 hours npm will take it down, right? So what we think is a better solution is, why not run npm run a tool on their end? Like when I upload a package, npm scans it and says if it is good I will publish, if it is not I will not publish. That's what we think. So is everything over? On 16th of March we had popular React packages, Axios, 30th of March. This is going on and sometimes more sophisticated than the before previous attack. That's it. Thank you for your time. If you have any questions.